Alright, today's lesson is over trigonometric ratios. Okay, so we'll be building off of our right triangles that we discussed. Yesterday we had the two special ones, the 30, 60, 90 and the 45, 45, 90. Those only work for those two triangles. What happens if we have a triangle that's 46, 44, 90? That's where these trigonometric ratios are going to come into play. A trig ratio is a ratio or a fraction of the lengths of two sides of a right triangle. The input, or what we're going to put here, how x is your input, y is your output, it's going to be the degree measures of acute angles. So we're looking for numbers, degrees that are less than 90 degrees. Okay, so 89 would be acute. Those are what we're looking for. The reason is if I have a right triangle already, the largest angle will be the right angle. The other two angles must add to 90 degrees. That way the triangle adds to 180. So automatically I know that each of these angles must be less than 90. Just as a refresher, since 90 is the largest angle, the side opposite of that is going to be my hypotenuse. I always have a really hard problem spelling this. If I spelled it wrong, I think there's an H there, but you know what I mean. Alright, and I know that in the past we have talked about rounding, and I will give you specific directions. In the case of trig values, it's very common and most often that you're going to round to 4 decimal places. I would expect that of you out of my classes as well. So even if I don't give you the directions that say round to the nearest whatever, you need to follow 4 decimal places when we're talking about trig. Alright, so the ratios is a fraction of the two side lengths of the triangle. Now there are 3 different types of ratios that we could have here: sine, cosine, or tangent. This symbol here is actually called theta, and theta is a Greek letter that we use to represent the unknown angle. So a lot of times we use x and y to denote what we don't know, our variable, what's missing. In the case of angle measures, you will always use theta. Okay, so that's with a th, a theta. Okay, now in the triangle there are 3 sides. So I'm going to draw a right triangle up here in the corner. The side across from 90 will always be your hypotenuse. Hey, I did spell it right without the H there. I can't remember. And then if this is the angle that we're looking at, the side, so this is theta, the side directly across from theta would be opposite. And the side that touches theta would be adjacent. Notice that hypotenuse also touches theta, but it's across from 90, so it has to be our largest side, the hypotenuse. So we have opposite, hypotenuse, and adjacent. Now, with these 3 sides, we can make 3 different fractions or ratios. So sine will be the opposite over the hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay? It's kind of important that we remember these, so I have a couple of different acronyms to show you. First off, you have Chief SOHCAHTOA. Sine is opposite over hypotenuse. Cosine, right? Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Alright, so if you don't like that, I have one that's really cute. I kind of like it. It's some old hippie caught another hippie tripping on apples, let's say. So we have SOH, sine is opposite over hypotenuse. CAH, cosine is adjacent over hypotenuse. And TOA, tangent is opposite over adjacent. Alright, so looking in this triangle that we have here, let me scroll down just a little bit so that you can see all of it. There we go. Alright, what we need to do here is find the sine, cosine, and tangent all from angle A. So this is my theta here. So the sine of A is opposite over hypotenuse. So the side opposite of A is going to be little a. Over hypotenuse is C. Okay? Now remember that the cosine of A is adjacent over hypotenuse. So adjacent to A would be B over hypotenuse C. Let's go ahead and mark that out for now. I don't want to confuse you. And then tangent is opposite over adjacent. So opposite of A is little a. Adjacent to A is little b. So these are my three ratios. Alright, so let's take a look at this problem here. I have theta here and theta here. It's our job to label opposite, adjacent, and hypotenuse. I always start with hypotenuse because it's across from 90 degrees every time. Alright, now, I know that the side that touches the angle that's not the hypotenuse must be adjacent. And all the way opposite of that angle would be the opposite side. So here in this case, I've moved to the theta down at the bottom, and I still have the hypotenuse in the same place. But this side down here is adjacent because it touches theta, and the side opposite of theta is here. Now there might be some other times that you see sine. For example, you may see sine of theta called up over hyp. Okay, that's opposite over hypotenuse. Cosine of theta would be adjacent, ADJ, over hyp. And tangent of theta would be up over ADJ. Okay, where ADJ is standing for adjacent, up standing for opposite, and hyp standing for hypotenuse. Alright, so let's put this into play. I want to find the sine, cosine, and tangent of angle A and angle B. So let's start with angle A here first. Alright, let's go ahead and label all the sides as it relates to angle A. The side opposite of 90 will be my hypotenuse. The side that touches angle A that's not the hypotenuse is my adjacent. And the side directly across from A is my opposite. Okay, so this is my angle here. Sine of A is opposite over hypotenuse. So opposite is 12, hypotenuse is 13. That fraction is 12 over 13. So we could say opposite over hypotenuse equals 12 over 13. Now cosine would be adjacent over hypotenuse. Adjacent is 5, hypotenuse is 13. So the cosine of A is 5 over 13. Tangent is opposite over adjacent. So 12 over 5. Alright, now I'm going to erase this, and this time we're doing it from angle B. So this is hypotenuse because it's still across from 90. The side that touches the angle is adjacent, and the side directly across from B is opposite. So if sine is opposite over hypotenuse, that'd be 5 over 13. Cosine is adjacent over hypotenuse, so 12 over 13. And tangent is opposite over adjacent, so 5 over 12. Alright, so right here we have two similar triangles. We're told that in the problem. So my job is to find this missing side length. I notice that the scale factor is 2 because 4 times 2 is 8. So 7.5 times 2 must be 15. Alright, so now we have all that we need to find the sine, cosine, and tangent of these two triangles. Now remember that sine of A, so we're going to start with A. Hypotenuse is 8.5 because it's across from 90. The side that touches angle A is adjacent, and the side directly across is my opposite. So sine is opposite over hypotenuse, or 4 over 8.5, which as a decimal is 0.4706. Remember in the beginning I told you that we needed to round to 4 decimal places. I expect this of you. Alright, cosine is adjacent over hypotenuse, so 7.5 over 8.5, which as a decimal is 0.8825, or 24, excuse me, going to 4 decimal places. Alright, and tangent of A is opposite over adjacent, so 4 over 4 4 over 7.5, which is 0.5333. Alright, what I want you to do is I want you to pause and try to find the sine, cosine, and tangent of the larger triangle right now. Alright, so this is what you should have gotten. A, the side opposite of that is 8, hypotenuse is 17, and adjacent is 15. So with these fractions, I've changed them to a decimal, and I've noticed that the ratios are exactly the same. That's going to happen with similar triangles because if I say 2 over 4 or 1 over 2, they both simplify to 0.5 or 1/2. They are similar ratios, okay, which means that when I break it down and simplify these fractions, I'm going to end up with the same decimal. Okay, that's important to know that your trigonometric ratios will be the same for similar triangles. Alright, so I want you to take a minute, pause this video, and see if you can find this sine of A. Alright, here's A. Opposite of A is 1. Okay, adjacent to A is square root of 3, and the hypotenuse is 2. So sine should be opposite over hypotenuse, so 1/2, or I would have also accepted 0.5. Now the reason that this decimal doesn't go out farther than this is because it is 0.5. There were no numbers that followed. Okay, so if you were uncertain, you could feel free to write 0.5000, but just remember it's 0.5. There's no rounding that is occurring here because it just is 0.5. Alright, take a minute, pause, and see if you can find the sine of B. Alright, so from B we need to label the sides. This is the hypotenuse, this is my opposite, and this right here is my adjacent. So sine is opposite over hypotenuse, so 1 over the square root of 2. Now the problem is we're not allowed to have radicals at the bottom, so type it in your calculator and you get square root of 2 over 2, whereas the decimal is 0.7071, 4 decimal places. Now in your calculator, I actually want you to find the sine button and type sine 45 and enter, and tell me what you get. Alright, so you should have gotten 0.7071. That's because angle B was 45 degrees. This is going to be very important because we'll be able to determine based on the side lengths what angle this is. Or based on the angle, what are the missing side lengths? Pythagorean theorem has restricted us to knowing that we have to know 2 of the 3 sides in order to find the missing side. However, trig allows us to find 2 of the missing sides given an angle and one of the sides. So this is where we're kind of going with this. So it's very important that you know how to label opposite, adjacent, hypotenuse. It's very important to know that sine is opposite over hypotenuse, that tangent is opposite over adjacent, and cosine is adjacent over hypotenuse. You may begin wanting to make flashcards and start remembering those. Okay? So we will continue tomorrow, and I will see you later.